Hello, class. Today we are going to cover the last section in Chapter 3, which is 3.7, Rational Functions. So in Chapter 3, we covered a lot on polynomial functions, and now in this last section, we're going to jump to a different type of function, which are rationals. Root word ratio, so we're going to be looking at functions that are made up of a ratio of two polynomials. Okay, so 3.7, rational functions. Okay, so let's make sure it's clear that we all know what a rational function is, or at least what it looks like. So I'll call it R of x. So it has this form where you have one polynomial over another one. Okay, so for example, maybe you might have something like 3x minus 5 over x squared plus 2x plus 1. Okay, so that would be a polynomial function. Let me call this R of x. Okay. What we're going to be doing here is we are going to be looking at how to graph these rational functions. So here are some things that we're going to be looking at when we graph. Okay, so when it comes to graphing rational functions, the idea of asymptotes play a big role. Okay, so we are going to be taking a look at what are called vertical asymptotes. So this is basically where R of x is undefined. So this occurs whenever we have the function undefined. So wherever the denominator is 0, right? So we're going to have a vertical asymptote there because those x values are going to be excluded from the domain because they make the domain 0. I mean, they make the function 0 in the denominator, which makes it undefined. Okay, so we will have vertical asymptotes where our function R of x is undefined. So if there are no x values that make the denominator 0, then we won't have any vertical asymptotes. Okay, so it's where R of x is undefined. So it's, i.e., it's where the denominator equals 0. Okay. So because this is where the function R of x is undefined, the graph will not cross here. Okay, so those are for your vertical asymptotes. And usually for the vertical asymptote, we just have sort of this vertical dashed line. Okay. The horizontal asymptote. Some students think that you can't cross that horizontal asymptote just like your graph can't cross the vertical asymptote. That's not true. Okay, so here what this one does, so the vertical asymptotes, they kind of show you which x values are excluded from the domain. Okay, but the horizontal asymptote, what this does, it actually shows you what the end behavior is going to be going towards. Okay, so So you have this horizontal line. And so this is the y value that your function will go towards as x gets very, very large, like a million, and gets very, very small, like towards negative 1 million. Okay, so end behavior goes towards this. And your graph can cross it, unlike the vertical. Okay, because what it does is it's the eventual end behavior. Okay, and we're going to look at how to calculate this, and there are basically two situations. Okay, so we'll look at this more. Okay, so we have vertical asymptotes. That's where our function is undefined. So it's where the denominator is 0. Okay, and our graph will not cross this because these are the x values that are excluded from our domain. And then we have the horizontal asymptote. This describes the end behavior of our graph. Okay, it gets closer and closer towards this y value, this here. Okay, and then we also have what's called the slant asymptote. Okay, so of course, if it's not vertical, if it's not horizontal, then it's going to be slanted. Okay, like that. And this is very similar to the horizontal asymptote. Your end behavior goes towards this. So it's basically your horizontal asymptote, but tilted. Okay, and it has the form, since it's a line, right? So it has the form y equals mx plus b. Okay, so of these three, vertical asymptote, that will be easy to identify. It's where the denominator is 0. Horizontal asymptote, I haven't gone over how to find this, but it's also pretty straightforward. I'll show you in a minute. The slant asymptote has this form right here, y equals mx plus b. So this is going to take a little bit of work. Okay, so this here, the slant asymptote, is found by doing long division. Because remember, we're dealing with a rational function. Let's go back up here. So we're dealing with this rational function right here. So you're going to be doing that division, p of x divided by q of x. Okay. All right. So one thing about these two right here, you will either have one or the other. And you'll see why in a minute. One or the other will occur, not both. Okay. Which makes sense, because if it's if these are supposed to represent the end behavior, how can you have two different end behaviors, right? Okay. All right. So when we're graphing, we're going to be looking for our different vertical, horizontal, slant asymptotes. Okay. And once we do that, then what we end up doing is making a table of points. Make a table of points for each section, and I'll explain the sections in a minute. Okay, so what happens is you could have, here are just some examples of your asymptote. So maybe you have this here, right? And let me do the asymptotes in red. Okay. And so maybe you have a vertical asymptote over here. And then maybe you have a horizontal asymptote over here. Okay. So that's an example of having a vertical asymptote and a horizontal asymptote. Maybe you have a slant asymptote. So maybe you have something like this. Maybe you have, let me go back to my red. Maybe you have a horizontal asymptote down below over here. Again, we'll go over how to find these. And then maybe you have a slant asymptote that looks like this. Okay, so just expect to find your asymptotes, and you could have a vertical and a horizontal. You could have a, oops. Okay, sorry about that. That's not supposed to be there. You can have a vertical and a slant. Okay, so erase this if you guys did that. Okay, you can have a vertical and a slant. So maybe you have a vertical over here. Okay. So again, you can't have both a horizontal and a slant. That's why I erased that there. Okay. And again, you'll see that why in a minute. Okay. So these are just some examples of different scenarios with your asymptotes. Here, let me do one more. Another one is maybe you don't have a vertical. Okay. So maybe you don't have a vertical asymptote. So maybe your graph only has a horizontal. Okay, so maybe it has just this. Okay, and no vertical. Okay, but these are just 3 different scenarios that you could get. There are more. You can maybe have more than one vertical. Here, let's just do one more. So maybe you have 2 verticals. Okay, so maybe you have a vertical there and a vertical here, and then maybe you have a horizontal here. Okay. So once you figure out all of your vertical, horizontal, slant asymptotes, then what happens is you come up with some points in the different sections and you start plotting. Okay. But for the most part, these asymptotes help to guide the behavior of your graph. Okay. Okay, let's see. All right, so we already talked about finding your vertical asymptotes. It's where the denominator is 0. So hopefully that's not too difficult to find. Okay, so let's talk about how to find your horizontal asymptote. Okay, all right, so suppose that you have this rational function. So maybe you have a polynomial up on top and a polynomial here on the bottom. Okay, so Case 1. Okay. The degree in the numerator, the degree of p of x, the degree of p of x is less than the degree of q of x. Okay, so the degree on top is smaller than the degree on the bottom. Okay, if that's the case, then you will have a horizontal asymptote. I'll just say HA, horizontal asymptote at y equals 0, just automatically at y equals 0. Okay, so let me do an example over here. So suppose that your r of x is x plus 1 over x squared plus 3x minus plus 2. Let's do plus 2 here. So if you have something like that, okay, so what happens here, this is actually a little more interesting than what it's going to seem. So let me change the sign of that, because I don't want to get into points of discontinuity. Okay, so let's do this. Okay, so let's do that. All right, so if you, and that's also squared. Okay, so if you have this, so again, the degree on top is smaller than the degree on the bottom. Okay, so here, the degree on top is 1. The degree on the bottom is 2. Okay, so we have this scenario where the degree on top is smaller than the degree on the bottom. Therefore, when I do my graph, right, then I will have a horizontal asymptote at y equals 0. Okay, which is that x-axis. So right here, I will have a horizontal asymptote. Okay, so that's just automatic. As soon as that degree is smaller in the numerator than the one in the denominator, y equals 0. Right there, that axis is going to be a horizontal asymptote. Okay. Case 2. Okay. Maybe your degree in the numerator is the same as your degree in the denominator. So if they're like, say, they're both degree 2s, then you have a horizontal asymptote at y equals a over b, and I'll explain what a and b are. Okay, where a and b are the leading coefficients. Okay. All right, so let's take a look at an example over here off to the side. Suppose that our rational function is this over here. Suppose I have 2x squared plus 3x minus 1. And suppose that I have 3x squared minus 5x plus 2. Okay, so we see that here they have the same degree. Okay, we're degree 2 up here. Okay, so degree equals 2. And down here, your degree equals 2. Okay, so both of these have degree 2. And so therefore, my A is this 2, and my B is this 3. Okay, so my horizontal asymptote is going to be at 2/3. Okay, so when you graph that, you would go over here and you would go to 2/3, which is between 0 and 1, right around there. And you would draw your horizontal asymptote. Okay. All right, so that's what I mean by this A over B right over here. Okay. All right. And then, so that's case 1 and case 2. Case 1, the degree is smaller on top. Case 2, the degrees are the same. There is no case 3 because case 3, if it's the degree on top is larger, you actually don't have a horizontal. You actually have an opportunity to do long division, and that's where you have the slant asymptote. So the case 3, where the degree on top is larger, produces a slant asymptote. Okay. Maybe we'll write that down here. So case 3, the degree of P of X is larger than the degree of Q. So if that's the case, then no horizontal asymptote. Okay, so there's no horizontal asymptote. So you only have a horizontal asymptote if you have the degrees the same. Okay, so only if the degrees are the same or if the degree on top is smaller. Okay, so over here, if the degree is larger on top, there's no horizontal asymptote. You have slant asymptote. And we would need the degree to be larger on top so we can do our long division. Okay, but we'll do more on this later. All right, so let's just kind of practice graphing with horizontal asymptotes and vertical asymptotes, and then we'll look at slants. Okay, so let's go ahead and take a look at the graph of r of x, which is equal to 1 over x, the most basic rational function that you can get. All right, so for our vertical asymptote, okay, so we'll do this in parts. Our vertical asymptotes. So that's where the denominator equals 0. Asymptotes. This thing is slower than I write. Okay. Vertical asymptotes. Okay, so the denominator, which is x, we want to know when that equals 0. Well, kind of obvious. It's when x equals 0. Okay, so that's where we're going to have a vertical asymptote. So I'm going to go ahead and draw that at x equals 0. Okay. which is basically that y-axis. Okay, so remember, vertical asymptotes is where the denominator equals 0. We don't have to solve here. If you had a quadratic down there, you would have to solve. Okay. All right, let's do part 2. Horizontal. Okay, horizontal asymptotes. Okay, so the degree on top is 0. And the degree of Q is 1. Okay. All right, so the degree on top is smaller, which means that I have a horizontal asymptote automatically at y equals 0. So remember, when the degree is smaller on top, it's automatically at y equals 0. If the degrees are the same, then that's when you do that A over B. Okay? All right, so right here, this becomes horizontal asymptote. Okay, so we've taken care of all of our asymptotes, so now we can go ahead and make a table of values. Okay, I'm going to do it over here so we don't lose our screen. Okay, so I'm going to choose points for the left side of this vertical asymptote. Okay, so I'm going to do that. So points on the left side of the vertical asymptote. So then I can choose I can't choose 0. So I'll choose -1, -2, and -3. And then I will choose points on the right side of the vertical. Okay, so again, I can't choose 0. So I'll choose +1, 2, and 3. Okay. All right, so we plug it into the original problem. Where is it? 1 over x. So 1 over x. So 1 over -1, 1 over -2, and 1 over -3. Okay, so we see here we do end up getting closer and closer to that asymptote on the left-hand side. So when we're at -1, here, let me put some tick marks. -1, we get -1. Okay. -2, we get -1/2. -3, we get -1/3. And we get closer and closer to that horizontal asymptote. Okay, so that's what we mean by end behavior. So we go towards these asymptotes, and it gets closer and closer. Okay, it's kind of crooked. Okay, let's see if we can do a better job with the next one. All right, so 1 over 1 is 1. 1 over 2 is 1/2. And 1 over 3 is 1/3. Okay, so over here on the right side of the vertical, +1, I get 1. +2, I get 1/2. And positive 3, I get 1/3. So again, we could see that the graph is going to get closer and closer towards this horizontal asymptote. Okay. So that's what you end up doing. Sometimes I allow students just to come up with 1 point to figure out if they landed in the top or the bottom here. But sometimes it can get tricky depending on what you choose. Because if you pick a point that's close to the horizontal asymptote, then you might be misled to think that your graph is in that quadrant. Okay, so doing 3 points is always good. Okay. All right. Let's have a look here. Let's try another one. Okay, so let's graph this one. So let's graph f of x, which equals 3x plus 5 all over x plus 2. Okay. So first things first, vertical. Okay, so our vertical asymptote, again, this is the one where the denominator equals 0. So let's take that denominator, x plus 2, and set it equal to 0. So when does it equal 0? When x equals, did you say -2? Good. Okay. All right, so let's start off with our vertical. So we have a vertical asymptote at x equals -2. Okay, so this x value is excluded from our domain, so it's excluded from our graph. Okay, so let's do the horizontal. Oops. We know we have horizontal because the numerator's degree is not larger. Okay, horizontal asymptote. Okay, so the degree on top is 1. The degree on the bottom is also 1. So we have a horizontal asymptote at y equals 3 over 1, which is 3. Right? That's the a over b situation when the degrees are the same. Okay, when the degrees are the same, it's the a over b. Okay. All right, so we have it at y equals 3. Okay, so at y equals 3, come on, pen. Okay, so at y equals 3, we have this horizontal. Okay, and so you see my red vertical and my red horizontal. It's like it creates these quadrants, right? So I'm going to go ahead and pick x values to the left of my vertical asymptote. Okay. So to the left of x equals -2. Waiting for this to scroll up. Okay. All right, so I'm going to choose points that are left of -2. Okay, so I'll pick -3 and -4 and -5. And then I'm going to pick points to the right of -2. So to the right of -2, I'll pick -1, 0, and 1. Okay. And let's go ahead and plug those into the original function. Let's scroll down a little bit. Okay, so -9 plus 5. Okay, hold on. Okay, so -9 plus 5 is -4. And -3 plus 2 is -1. So we get 4. Okay. -12 plus 5 is -7. And -4 plus 2 is -2. So that's positive 3.5. Okay, -15 plus 5. Bring this up. Okay, -15 plus 5 is -10. And -5 plus 2 is -3. Okay. So we get positive 3 1/3, which is basically, yeah, 3 1/3. Closer to the, now we're getting closer to the asymptote. Okay. All right, let's do the other table. Can't see my function. All right. -3 plus 5 is 2 over -1 plus 2 is 1. Okay. Plug in 0, we get 5 over 2. That's 2.5. Okay. And plugging in 1, I get 3 plus 5. That's going to be 8. And 1 plus 2 is 3. So we get 2 2/3. Okay, so let's go ahead and plot these. So we have a point at -3, 4. 1, 2, 3, 4. -4, 3.5. And -5, 3 1/3. 1, 2, 3, 4, 5, 3 and a little bit more. So I can see here that my graph would be going towards that horizontal asymptote. So I get one branch over here. We see it getting closer and closer. Okay. And then on the other side, on the right side of -2, let's see what our points are. -1, 2. 0, 2.5. And then 1, 2 2/3, which is 2.67. Getting closer to that asymptote. Okay, so we see that we have another branch that goes here and gets closer and closer to that asymptote. Okay. All right. Let's take a look at one that has more than vertical. Actually, before we do that one, let's take a look at a case 3 where we have the slant. Okay. Okay, so let's go ahead and graph h of x, which equals to x squared minus 4x minus 5 over x minus 3. Okay, so we see that the degree up here is 2, and the degree down here is 1. Okay, so when the degree on top is larger, that's when you're going to have this slant asymptote, because we want to, in order to get the slant asymptote, we need to be able to do this division. And the only way you can do this division is if the degree in the numerator is larger. Okay, so degree larger on the top allows for the long division and gives us the slant asymptote. Okay, so we're going to do the long division. To get the equation of our slant. This is our slant equation. Because we still have to graph that line, right? Okay. All right. So let's go ahead and do that. X minus 3 and x squared minus 4x minus 5. So x times x is x squared. Okay. So let's go ahead and distribute. So I get x squared minus 3x. So let's go ahead and subtract. So these guys cancel out. This becomes a positive 3x. Okay, so that's, you have to distribute that outside negative. So that becomes a positive 3x. So positive 3x and minus 4x is negative 1x minus 5. Okay, so x times negative 1. And I could stop right there because now I have my mx plus b answer up here. Okay, so once you have your mx plus b, you can stop. Okay, so can stop. Okay, if you want to keep going, you can. You would get negative x plus 3, and you would subtract that, blah, blah, blah. But you don't need all of that because you only need the mx plus b part. Okay, so your slant, where's that n? Okay, so your slant is going to be this equation, y equals x minus 1. Okay, and we can see here in the denominator, x minus 3. So we're going to have a vertical. X minus 3 equals 0. So at x equals 3. So these are going to be your two asymptotes. This one, this slant one, will be an asymptote. And this one right here, x equals 3. So let's go ahead and graph our two asymptotes. And then we'll do the same thing we did previously where we choose values. Okay, so if we go ahead and graph this. Okay, so we have a vertical at x equals 3 that is being excluded from our domain. Okay, so x equals 3. And then y equals x minus 1. So hopefully you remember how to graph that using the shortcut method. Okay. Okay, so using the shortcut method over here, so we're going to plot our point at our y-intercept at -1. And then our slope is 1 over 1. So we're going to rise 1, run 1. And that puts a point right over here. And so this is going to be my slant asymptote. Okay. But you still see the 4 quadrants created by these 2 asymptotes. So then you make your table of values. Okay. Again, you're going to choose points to the left of 3. Left of 3. So I'll choose 2, 1, and 0. And to the right of 3. Do you have to? No, but I mean, you'll need to figure out what the 2 sides are doing. Okay, so to the right of 3, I'll choose 4, 5, and 6, I guess. All right, calculator handy. Okay, where is my original? X squared minus 4x minus 5. I'm going to write it over here so I can see it. X squared minus 4x minus 5 over x minus 3. Okay, so that's my original function. Okay, my Chromebook is slowing down now. Okay, 2. So I get 2 squared, which is 4. 2 times 4 is 8, minus 5. And 2 minus 3 is -1. Okay, so then this here gives me -9 over 1. So that's 9. Okay, plugging in 1, I get 1 minus 4 minus 5 over -2. So I get -8 over -2, which is 4. And then 0, we get 5 over 3. Or 1 2/3. Okay. 4, 5, and 6. Okay, 4 squared. Here. Scrolling. Come on. Okay, there we go. All right. 16 minus 16 minus 5 over 1. Okay, so that gives us -5 over 1, which is -5. Okay, let's plug in 5. Plug in 5, we get 25 minus 20 minus 5 over, oops, that's positive. No. 5, 25, -20 minus 5, 5 minus 3, 2. Okay, so we get 0 here. And then plugging in 6, we get 36 minus 24 minus 5 over 3. And what does that give us? +7. over 3. Okay. 2 1/3. Squeeze that in there. All right, let's see. Let's see what we get here. Okay, so hopefully we did all the calculations correctly. If not, I'll check it again. All right. 2, 9. So that's way up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So way up there. Okay. So 2, 9. 1, 4. 1, 2, 3, 4. And what is that last number? 0, 1 2/3. Okay, so we can see here, and so that's what I meant earlier when I was talking about how the asymptotes kind of form the behavior of the graph. So we can see here that it's going to be doing this deal. Okay, and then over here, 1, 2, 3, 4. For the other set, 1, 2, 3, 4, 5, and 6. 4, -5. Down here, 5, 0 over here, and 6 and 2. What is that? 3 1/3 it was? I don't remember. And I'm waiting for this to scroll. 2 1/3. Okay. So 2 1/3. So here, again, it starts to follow the behavior of your asymptotes. Okay. It's kind of messy here. Okay, so that is basically it. So here I just wanted to give you an example of how you would go about finding that vertical, that slant asymptote. And again, you would need to do this long division right here. And the only way you can do that is if the degree of the polynomial in the numerator is larger. So that's why case 3, degree larger on top, will give you the slant asymptote, no horizontal. Okay, so that is about it. So just make sure that you make a table of values so that you can get a more accurate graph. Okay, so if you have any questions, again, make sure you text me through the Remind app or email me or schedule a Zoom, or you can even request that I do a video on a particular section, like, oh, can you just kind of go over slant asymptotes in a video, and I can just do all slant asymptote examples. Okay. All right. Make sure you keep up with the homework. The homework is such a huge part of your grade now that everything is online. Okay. All right. Enjoy your day. Bye.